Welcome everybody to section 2.5. We're doing the introduction to functions today. Here we're going to start with data in a table. Data in a table can be written like this. As you can see here, we have a column on the left, column on the right, and all of these data points can be written as what? They can be written as ordered pairs. Okay, so these can be written as ordered pairs. Now, one thing I want to preface, so we already started, but this is going to be a longer section, so this is going to be split up into multiple videos, so buckle up, people. So we have hours worked and the paycheck. As you work a certain number of hours, you're going to be paid a certain amount of money, so that's why these have two different values. Now, generally, we have the inputs on the left, X, and we have the outputs on the right, and they're Y. So if we wanted to, we could make this into an ordered pair, which is a point on the coordinate plane. This would be our X value, this would be our Y value. Now our inputs are what we're putting in to this data table, and the outputs are how the inputs, they're related to the inputs. They tell us what is the result of the input. So if we work 5 hours, we know we're going to get paid $40. So that would be our first ordered pair there. So data in a table can be written as ordered pairs. And as we can see here, erase that guy, we can write this also. There's another one. So 2160 would be another example. So 2160 is another ordered pair. It's another data point on our chart. Now, these are examples, ordered pairs are examples of a function. This data table is an example of a function. So what is a function? A function is where each input has only one unique output. Okay, so keep that in mind. That means, in parentheses, I'm writing this, each X has only one Y. Okay, as we consider this a little bit more fully, we're going to understand this a little bit better. Now, here's our first example. We have this function f, and it's only composed of 3 points. So what are our inputs? Our inputs are all the x values. So we can label the x values, and these are going to be our 3 inputs. So we have 1, -2, and 3. As you can see, we only have one of each type of input. There's only one 1, there's only one -2, and there's only one 3. Okay, what about our outputs? Here we have 2 when we input 1, we have 4 when we input -2, and we get -1 if we input 3. This is an example of a function. Each input only had one unique output, so that's good. Okay, let's move on to the next example. Okay, so we're going to start off with our inputs. Our inputs are at -4, -2, and -2. And our outputs. Okay, so we labeled our x's and we labeled our y's. So now we're onto our outputs. We have 1 here, and then we have 1. Now let's stop here, okay? Now, look at our first column. We have input of -4, and we got 1 as the output. That's all good, okay? We can do that. Our second one, we had an input of -2, and again, we got an output of 1. Is this allowed? Yes, okay? So we can, outputs can repeat. Outputs can repeat. That's okay, because look, the -4, it's only had one unique output, and that was 1. The -2 only had one unique output, and that was 1. Okay, but then this guy blows it. Okay, the -2 and the next one blows it. So we have -2 is the input, and we have 0. So look here. If we were to look at this, we see, okay, both of these are -2, but we have 2 different values for -2. That's not a unique value. Okay, -2 having 2 outputs cannot happen. So essentially, what you can add here is inputs cannot repeat. Okay, so that's the general rule. They can't repeat. It's almost assumed that they're going to have different outputs. If we have -2, 1, -2, 1, that'd be different. But what's the point in having that? So inputs cannot repeat. I'm going to put just here with different outputs, just so you know. Okay, so that was just point ordered pair notation. We're moving on to mapping notation. So here we have relation F. I'm going to have a little separation there. Separate these two. We can write our inputs here. So we have 1, -2, 3. And then our outputs here. We have 2, 4, oops, a little struggle here. 2, 4, and -1. Now, mapping notation means we're going to show how each one of these maps to their unique value. So 1 maps to 2, -2 maps to 4, that ugly 4 there, and then 3 maps to -1. So you can see that each input, these are inputs on the left, only has 1 arrow. Okay, so that's another way to think of it. Okay, so each input can only have 1 arrow. Can only have 1 arrow. Okay, moving on to relation H. Now, this was a case that broke the law. We had too many inputs. We had a repeat of input. Let's see what this looks like as we put it into mapping notation. So we have -4 here, -2, and -2. Then we have 1, 1, 0. We can have 2 outputs. That's okay. Okay, so let's show what this looks like. And actually, I'm not going to write the, because we already wrote the -2, I'm only going to show that once, and I'm only going to show the 1 once as well. We don't need to write it twice in mapping notation. Okay, so let's see what this looks like. As you can see, we have -4 and 2, both mapping to +1. That's okay. The whole point of a function is that each input only has 1 unit. If I can draw this line, that'd be great. All right, try to talk here. So we have -4 with 1 arrow, -2 with 1 arrow. That's fine. Even though the output receives 2 arrows, that's not important. Now, what is problematic, my goodness, what is problematic is if we have -2 with 2 arrows. So this cannot be a function because we have -2 maps to 2 outputs, which you can't have. Okay, so each input can only have 1 unique output. So guess what? Relation H is not a function. Relation H is not a function, whereas F is. F is a function. F stands for function. That's not always going to be the case. Now, there's another way. So we talked about ordered pairs. We talked about this mapping notation. We can also graph these points. So these are points on the coordinate plane. F, what do we say? We'll make this green and then we'll make pink for the other one. So let's make our points here. We have the point. This is our x value. This is our y value. So we have the point 1, 2 is a point. We have -2, 4. -2, 4. There's a point. And then I have 3, -1. There's a point. So as you can see, this is a function here. Okay, each x input only had 1 y output. Now let's go to relation H. The same cannot be said of this guy. Let's change this to pink. So we had -4 mapped to 1, so we go to -4, we go to 1. -2 mapped to 1, so far so good. But then we also had -2 mapped to 0. Okay, so it looks like this in the coordinate plane. All right, now what I'm going to do is I'm going to connect this with a line, just so you can see both of these a little bit more clearly. And there we go. Those are 2 functions. So this is F, and this is H. Okay, moving on. We're going to come back to this, promise. Functions can be, oh my gosh, can be a relation defined as, so okay, so then you didn't see that. Just erase that. We already know I make some mistakes with spelling in these videos, but please forgive me. All right, so functions can be a relation defined as a set of, we already talked about this, ordered pairs. We talked about this at the beginning. It can be a table. We talked about this in the most recent section. Ooh, struggling here. A graph. And then it can also be an equation. Okay, that's the new one. It can be written as an equation. One such example would be y equals 2x. The x are the inputs, and then the y is the output. Okay, so you could input any such number and you'll get one distinct output. That's the definition of a function, okay? So for example, I'll tell you what a function wouldn't do. A function, if you input the number 0, so you input the number 0, you wouldn't get like 3 things. 1, 2, and 3, okay? That wouldn't happen. That wouldn't happen in a normal equation, okay? And I'm going to demonstrate that now. So this equation that we're given, this is our kind of like function machine, okay? Should I write that? I'll write it. Function machine. Okay, this is a way of understanding functions. So with a function, we could input something. Let's say we're going to input 5. Why not? We input 5. What comes out? So we input 5. This is our value of x. So if we input 5, we get y equals 2 times 5. We get 10. So as we put in 5, we get one output, and that is y equals 10. Okay, you could do this again. You could choose -7 for x. This is a separate input. Okay, so let me find a separate area. X equals -7 input. Okay, then our output, we put in -7. I'm going to go down here, show you the work. Y equals 2 times -7 for our input. We get -14. So we had only one output, and that was -14. All right, so that's how a function works. And I think this will be a good time to end this part 1. This is all about functions. Please join me for part 2 when we talk about domain and range. That's really a trouble spot for a lot of students. Hope to see you later.